Find the inverse of the following matrix of order 3 by 3. You know the definition of A inverse. It is 1 by determinant A into adjoint A. So let us first find the value of determinant A, that is determinant 1, 0, 0, 3, 3, 0, 5, 2, negative 1. Obviously, because in row 1 you have 2 zeros, so we'll expand along R1, and you get 1 time, delete the row and column through 1, you get 3 into negative 1, that is negative 3, and minus 2 into 0, 0, so you get negative 3. So what is the value of determinant A? We find that finally determinant A is minus 3, keep it with you. Now let us work out adjoint A. Now, how do you find adjoint A? What is the definition? It is defined as the transpose of a matrix where each element is replaced by its cofactor. This being a 3 by 3 matrix, so adjoint A is transpose of C11, C12, C13, C21, C21, C22, C23, C31, C32, C33. To find the cofactor, you delete the row and column through a particular element and work out the value of minor, that is the remaining determinant, and impose the sign. Sign convention, plus, minus, plus, minus, plus, minus, plus, minus, plus. This way. So now, I think you can work out this yourself. I'll calculate 1 or 2 for you. Like for example, C11 will take plus times, delete the row and column through A11, that is 1, and you left with 3, 0, 2, minus 1. Work it out, you get minus 3, 0, minus 3, minus 0, so minus 3 only. And outside is plus sign, so it will remain minus 3. Then C12. For C12, the sign is negative. Negative sign to be imposed on the value of determinant obtained by deleting the row and column through element 1, 2, that is through 0 here, and you get 3, 0, 5, minus 1. 3, 0, 5, minus 1. So when you work out, you get minus times minus 3 and of course minus 0, so minus minus plus 3 you get. So similarly, you can work out the other cofactors yourself. I am directly replacing. So the value of adjoint A will be the transpose of, just work out the cofactors out here with proper signs and write down in order. So you get minus 3, 3, minus 9, 0, minus 1, minus 2, 0, 0, 3. And now take the transpose, the elements of the first row to be written in the first column, negative 3, 3, minus 9. In that of the second row are 0, minus 1, minus 2 you write in second column. And the elements of third row 0, 0, 3 you write in the third column, that is adjoint A. And hence, now A inverse as per definition is 1 by determinant A into adjoint A. We have already worked out adjoint A is 1 by we have worked out determinant A is negative 3. So it is 1 upon negative 3 times adjoint A, which you worked out as negative 3, 0, 0, 3, negative 1, 0, and negative 9, negative 2, 3. So this is the required value of A inverse. Find the inverse of the following. The definition of inverse is 1 by determinant A into adjoint A. Let us first work out the value of determinant A, that is determinant of the given matrix 2, 1, 3, 4, minus 1, 0, and minus 7 to 1. Work out the value of determinant A. So determinant A you may work out with respect to any one row or column, but it will be convenient to do it with third column because at least one 0 is there. Okay, and you know the sign convention, plus, minus, plus, minus, plus, minus, plus, minus, plus. And we are doing it with third column, so it will be 3 times, delete the row and column through 3, you get 4 into 2, 8, and minus, minus, plus 7. And then second element being 0, though it was negative but doesn't matter, 0, and third element is plus 1, time you delete the row and column through 1, you get 2, 1, 4, minus 1. So you get 3 into 1, that is 3 plus 1 times, 1 time minus 2 into minus 4. So you get 3 minus 6, that is minus 3. So what is the value of determinant A? Determinant A is minus 3. And now let us work out adjoint A. You know the definition of adjoint A. It is transpose of a matrix obtained by replacing each element by the corresponding cofactor, that is C11, C12, C13, C21, C22, C23, C31, C32, C33, and take transpose of it. Now how do you work out the cofactors? That is, delete the row and column through that particular element, work out the value of the remaining determinant, and impose the proper sign which is already there as plus, minus, plus, minus, minus, plus, minus, plus, minus, plus, this. So let us work out some of them. See, C11. What is C11? It will be plus times obtained by deleting the row and column through 2, and you will get minus 1, 0, 2, 1. So when you work out, you get minus 1 into 1, minus 1, into minus 0, so it is only minus 1. Then what is C12? C12 of course will be negative times, delete the row and column through 1, and you get 4, 0, 4, yes. So the value of C12 will take negative times, delete the row and column through 1, 2 element, that is say 1, and you get 4, 0, here you get 4, 0, negative 7, 1. So negative times 4 into 1 is 4, so negative 4 minus 0, so you get negative 4. Similarly, you can work out C13, and C13 will be C13, for 1, 3 element it will be with, this was C12 negative, and C13 will be with plus sign, delete the row and column through 3, you get 4 minus 1, 4 minus 1, and minus 7, 2, minus 7, 2. So you get minus sign, in C13 plus sign is out, you get 8 and minus 7, minus plus 7, so 8 minus 7 is 1. So now we have worked out C11 as minus 1, C12 minus 4, and C13 as 1. Similarly, rest of the cofactors you try yourself and substitute in the definition of adjoint A. What is adjoint A? It is the transpose of, replace the value of C11, C12, C13 as negative 1, negative 4, 1, and C21, 22, 23, etc. you work out yourself. You will find 5, 23, minus 11, 3, 12, minus 6. Take the transpose. The elements of the first row, that is negative 1, negative 4, 1 you write in the first column. That is the second row, 5, 23, minus 11 you write in the second row. And the elements of the second column, and the elements of the third row, that is 3, 12, and minus 6 you write in the third column. So we get adjoint A. And once you get adjoint A, then you know A inverse is 1 by determinant A into adjoint A. And what is the value of determinant A? We have already worked out as negative 3. So it is 1 upon negative 3 times adjoint A, which you worked out as negative 1, 5, 3, negative 4, 23, 12, and 1, negative 11, negative 6. So this is your A inverse.